All right, let's talk about something that's happening all around us, but mostly behind the scenes. The incredible, complicated relationship between artificial intelligence and energy. It's a massive paradox, and it's reshaping our world in ways you might not expect. So, let's dive right in. If you want to understand just how huge the AI boom is, you just have to follow the money. It's pretty staggering. Since ChatGPT really took off, AI companies have been responsible for 75% of the growth in the S&P 500. We're not talking small numbers here. That's a $12 trillion surge. This isn't just some passing trend. It's a full-blown financial revolution.
But here's the thing. Behind every single one of those dollars, behind every search query and every image generated, there's a real physical cost, a cost we measure in electricity. And that brings us to the core of it all. What is the hidden energy footprint of this digital gold rush?
Okay, so let's start with the first part of the paradox, the problem. And it's a big one. To put it simply, AI has an absolutely insatiable appetite for power. You know, when we talk about AI's energy consumption, what we're really talking about are data centers. And it's not just the servers themselves, the computers doing all the hard work. You have to keep all that equipment from literally melting. That means you need enormous cooling systems, reliable power, the whole shebang. And the scale, it's just wild. Just to manufacture the chips that power all this AI, that process alone uses over 100 terawatt hours of electricity a year. And get this, that's just one part of the supply chain, and it's already using about 1% of all industrial electricity on the entire planet. Let's bring it down to something you can picture. A single high-end GPU, one of the workhorses of AI, can pull as much power as your kitchen toaster. Now imagine a warehouse filled with not one, but tens of thousands of those toasters, all running at full blast 24/7. And you can see how that just explodes. To train a massive model like GPT-4, it took an estimated 22 megawatts of power. So what does that actually look like? Well, it's basically the same as having 150 of those super fast electric car chargers all going at the same time, full blast.
So you can see how this creates a huge headache for our power grids. They need more power and they need it yesterday. But look at the options. You could build a new solar farm, totally clean, which is great, but that could take up to 4 years. On the other hand, you could get a natural gas turbine up and running in just a year. Much faster, sure, but it comes with a heavy carbon price tag. It's a real-world trade-off between speed and sustainability.
Okay, so that's the problem. It sounds pretty intense, but remember, this is a paradox. So let's flip the coin and look at the incredible promise here, because AI could also be one of our most powerful tools for saving energy. Let me give you a perfect real-world example. Methane is a super potent greenhouse gas that leaks from oil and gas pipes all the time. The old way of finding these leaks was literally sending people out to walk the pipelines. Slow, expensive, and not very effective. But now, we have AI that can scan satellite data and instantly, boom, pinpoint the leak hotspots from space. That means crews can get there faster and fix them, slashing emissions. It's a total game changer. And this isn't just for methane leaks. This same potential exists across our most energy-hungry industries. Think about the processes for making iron and steel, or chemicals, or cement, the very foundations of our world. AI can analyze these super complex systems and find efficiencies that humans never could, unlocking huge energy savings. AI can also just make our current energy systems a lot smarter. By using it to predict when a piece of equipment in a power plant might fail, we can fix things before they break. That kind of predictive maintenance could cut operating costs by up to 10%. Globally, that's a saving of around $40 billion every single year.
But just optimizing the stuff we already have is really only the beginning. The truly transformative part, the thing that gets me really excited, is AI's potential to actually accelerate how we invent our clean energy future.
Think about it like this. Historically, big breakthroughs in energy take a really, really long time. It took solar panels more than 30 years to go from a lab prototype to something that could power a city. The lithium-ion batteries in your phone and car, that was a 14-year journey. Frankly, we just don't have that kind of time to wait anymore. And this is where AI could completely rewrite the rulebook. It has the potential to shatter those old, slow timelines, to compress decades of research and development into just a fraction of the time. So how does it do that? Through incredible new ideas like the self-driving lab. It sounds like science fiction, but it's real. An AI model comes up with millions of new hypothetical materials. Then a robot in the lab automatically creates the ones that look most promising. Another machine tests them. And here's the magic. The results are fed right back to the AI, which learns and makes an even smarter prediction next time. It's the scientific method on hyperspeed. And the targets here are basically the holy grails of the energy transition. We're talking about discovering new materials for cheaper, longer-lasting batteries, designing super-efficient solar cells, finding better ways to capture carbon right out of the atmosphere, even creating clean synthetic fuels from scratch. So this brings us all the way back to where we started, to our paradox. We've created this incredible technology that has a massive new thirst for energy, but it might also be the most powerful tool we've ever had for solving our energy problems in the first place. When you get right down to it, it's a race. In one lane, you have AI's own skyrocketing energy demand. In the other lane, you have all the potential energy savings and clean energy breakthroughs it could help us create. The billion-dollar question is, which one is going to win? Which of these bars is going to grow faster? And that leaves us with one last question to think about. AI is arguably the most powerful tool humanity has ever built. So the choice is really up to us. Are we going to use this incredible power to build a sustainable future, or are we just going to use it to burn through our resources even faster? The final chapter hasn't been written yet,